Hi all, I hope you're doing well. Today we are going to move on to the second part of our lesson 10 on understanding each part of the circuit. Right. So as you might remember, yesterday we learned all about the different components necessary to have a closed circuit that works properly. But we still don't have a solid understanding on what causes the energy to flow in a circuit. Today, we are going to learn all about potential difference or voltage in order to be able to truly answer our driving question from yesterday of what is the function of each component of the circuit. We are also going to be going in depth into what potential difference is and what is its function within the circuit. Today, we will be gathering evidence from a detailed video and also be doing some reading to help make sense of what potential difference actually is. Right. We're also going to be answering some questions that we'll go over the answers as a group, and then we'll have an exit ticket at the end. So make sure you have your notebooks out so that you're able to make sketches and take notes and write down key concepts. This is really important because we're going to be referring to these key notes and concepts throughout the rest of today and also throughout the rest of this unit. So you should have all this stuff written in your notebooks and not in the classwork document. All right, so let's start by watching this video on potential difference. I am going to be pausing the video periodically to make important points that you should be writing down, or to highlight important points you should be writing down. All right, so let's start.
Imagine you have two beakers filled with equal amounts of water, and they are both connected to each other by a pipe at the bottom. If you observe the two beakers for a few seconds, do you think the water will flow from one beaker to another? No, you will see that the water in both beakers is as is, and there is no flow from any beaker to the other. Now let me give you a task. Without changing the amount of water in any of the beakers, can you make water flow from beaker 2 to beaker 1? Understand my question again. You need to make water flow from beaker 2 to beaker 1. But you're not allowed to change the amount of water in any of the beakers. So you can't add or remove the water from any beaker. How will you do it? It's easy. One of the things you could do is raise the height at which the second beaker is kept. Once it's raised at a height, the water will flow from beaker 2 to beaker 1. What exactly happened here? What was the factor that made water flow? In simple terms, the factor was height. Yes, you can talk about gravity or pressure difference. But in layman terms, it is the height difference that causes the water to flow from the second beaker to the first. In an exactly similar way, for electricity to flow, there has to be some factor. We'll come to that factor soon, don't worry. So if we just have a copper wire, do you think electricity will flow through it? Clearly not, because there's nothing that's triggering it. There's no factor triggering it. So what is the factor that triggers the flow of electricity? It's called the potential difference. Now I can define the...
Okay, so let's pause that for a second. So she just said that potential difference is the factor that triggers the flow of electricity. So please write that in your notebooks right now. I am going to say it one more time. Potential difference is the factor that triggers the flow of electricity. Okay, let's keep going.
This term in one line, but that wouldn't help you understand the concept well. So let's dive a bit deeper into it. We see the word potential here. Have you heard this term before? Of course, we've heard of potential energy. It is the stored energy when an object is at rest. When you're holding a ball in your hand, it has potential energy. When you drop it, the potential energy is getting converted to kinetic energy when it drops to the ground. Kinetic energy is the energy an object has when it's in motion. Similarly, there is a concept of electric potential energy. The electric potential energy of any charge describes how much stored energy it has. Just like the ball in your hand has high potential energy, a negative charge close to another negative charge has high potential energy. If left free, the charge will be repelled by the negative charge and will move towards the positive charge, just like the ball will fall towards the earth. What's potential difference then? It's just a difference of electric pressure between 2 points. And this difference may...
Sorry, I'm going to pause here for a second. Can you guys write in your notes, how is electric potential energy similar to a ball falling to the pull of gravity? If you need to rewind this video to catch that, then please do that now. But in your own words, in your notes, again, write, how is the electric potential energy similar to a ball falling to the pull of gravity? You can pause the video or rewind if you need to go back and look. Okay, let's move along. So now we're going to go on to actually define what potential difference is.
It's just a difference of electric pressure between 2 points. And this difference may arise because of a battery consisting of cells. Potential difference is also referred to as voltage. If we have to understand the technical definition, we would say that it is the work done to move a unit charge from one point to another.
Okay, so we have a formal definition of what potential difference is now. Another word for that is voltage. So please write this down in your notes. The potential difference is work done to move a unit of charge from one point to another. If you need to pause the video to have this, to write this down, you can do that now. Okay, let's move on.
The potential difference V between any 2 points in an electric circuit will be the work done over the charge Q. We know that the work is measured in joules and charge is measured in coulombs. What's the SI unit of potential difference then? It's volt, named after Alessandro Volta, an Italian physicist.
Okay, please write this down also into your notes, the equation for potential difference. So write all of this out, where the potential difference between 2 points is equal to the work done divided by the charge. Remember, this is joules, or the unit for work. We learned about that back in our energy unit. And in the beginning of this unit, we discussed how the unit for charge is called a coulomb, named after the physicist that discovered charges. Right? And then the unit for potential difference as a whole is called a volt. That is also named in an honor for Alessandro Volta. So finish writing this down. And if you need to pause to get this all done, then you can do that now. And I'm going to move on. Oh.
It is the potential difference between any 2 points when 1 joule of work is done to move a charge of 1 coulomb from one point to another. The potential difference is measured by an instrument called voltmeter.
Okay. We're going to stop here. We're going to discuss what voltmeters are later on, but you didn't need to know that now. All right. Also, for your reference, this video is linked at the bottom of your classwork document if you want to go back and watch it again after the lesson. Okay. So let's move on to the next thing. Oops. Okay, so our first check for understanding. The quantity electric potential is defined as the amount of what? Take the next 30 seconds or the next minute to answer this question in your classwork document. Okay, so the answer for this one is C. The amount of electric potential is defined as the amount of potential energy per charge. Right, so correct your classwork document if you need to. All right, moving along. So here is our next check for understanding. So complete the following statement. In your classwork document, this is there, so you can type in your answer there as well. When work is done on a positive test charge by an external force to move it from one location to another, the potential energy will increase or decrease, and the electric potential energy will increase or decrease. All right, so take the next minute to answer this question. You can press pause now if you need. All right, so let's go over our answers. So the correct answer in both of these cases actually is that they're both going to increase. So if a positive test charge is moved, then by an external force, then the potential energy will increase. And by increasing the potential energy, its electric potential will also increase. All right, let's move on now to a key point that you should write into your notes. Energy moves through a circuit, and that energy is carried by the electrons. This energy is supplied by the battery. And the unit of this energy is called a voltage, and which measures the strength of the battery, and that is equivalent to 1 joule per coulomb, like we saw in the video. If you look at the batteries of the things that are around you, like you'll see that has the voltage in them, like labeled on them. So for example, you probably won't be able to see this, but I have a battery here that I took out earlier from the remote control. And if you look at the very, very top in the black part there, it actually says 1.5 volts, so 1.5 volts. So that's how much potential energy, the potential difference is in this battery here. And then the remote at my mom's house has a space for 2 batteries, like most remotes do. So what do you think that means in terms of the total voltage that the circuit has? Just think about it for a second. If there's 2 batteries that have 1.5 volts. You're right, the total voltage that the circuit of this remote control has is 3 volts, because you just add them together. Okay, moving along. Okay, so just a quick revisit of our agenda. We watched the potential difference video and did a few check for understanding. So now we're going to move on to the reading about potential difference and some more questions we're going to work together. All right, so in your classwork document, there is a reading that you're going to take the next 5 minutes to annotate and into your classwork document. You can press the video now, and I'll come back when you're ready. You can press pause now. Alrighty, let's move along. So let's check our understanding from the reading. So in your classwork document, take the next minute to answer this question. If moving an electron within an electric field would change the what of the electron? Press pause to answer this question. Alrighty, so now let's look at your response. So the correct response should have been the potential energy of the electron. Right, so the mass of an electron will never change, and the charge of an electron actually itself is also never going to change. So even if you move them within a field, like none of those are going to happen. So it's just the potential energy that changes. All right, moving along to our next question. Also going to take a next minute to read this question. Once I'm done reading it, you can press pause so you can answer it for yourself. If an electrical circuit were analogous to water circuit in a water park, then the battery voltage would be comparable to what? The rate at which the water flows in the circuit, the speed at which the water flows, the distance that the water flows, the water pressure between the top and the bottom of the circuit, or the hindrance caused by obstacles within the path of moving water. All right, so press pause and answer this question. Alrighty, so let's check to see what your answer should have been. And the answer should have been D, that it's analogous to the water pressure between the top and the bottom of the circuit. Similar to what the woman was explaining in the video of how the height changes, how water flows, in like the beaker example. We're going to revisit this question again tomorrow. All right, so another analogy that is often used to describe potential is escalators. This isn't what actually is happening, but you can kind of, it helps us understand. You can imagine like electrons are kind of on an escalator inside of the battery, which allows it gives it more energy to be able to go around a circuit. So you can think of those like batteries just kind of like if they had like a mini escalator inside where the electrons are like riding, they're going up, and then they get to go around the circuit, and when they reach the bottom of the battery, they're at the bottom of the escalator again, and then they go back up the escalator, and then they have the energy to go around the circuit again. Again, that's not exactly what happens, but it's a helpful analogy to understand. Alrighty, moving along. So our last check for understanding, I think this is one of the most difficult questions for today. Take the next 2 minutes to answer this question for yourself. Once I'm done reading it, press pause so you can take those 2 minutes, and then we'll come back and go over the right answers. So following the following circuit consists of a D-cell battery, which is the batteries that you have in like those thick D batteries, that's what a D-cell battery is, and a light bulb. So use a greater than, less than, or equal symbols to compare the electric potential at A to B, and then at point C to D. Indicate whether the devices add energy to or remove energy from the charge. Right, so does the battery remove energy or add energy, and does the light bulb add energy or remove energy? All right, so you can press pause now to answer this in your classwork document. Okay, let's look through the answers. All right, so here we have the correct response for each part. So let's actually discuss what's going on here. So here we have that the potential difference between B and A at these points, A is less than B. And that's because at this part here, what's happening is the electrons are coming out of the battery, right? And so this point is going to have the highest potential in the circuit. And then the electrons are flowing around, they're doing their thing. And then they're kind of like going up the escalator here. That's the example. So they go up the escalator and they're riding around. They get to this point D here, and once they go through the light bulb, they're losing energy. So it's kind of like they're going down an escalator here. So removing energy down escalator, if you want to think about it like that. Ooh, escalator. And then from point C, they're kind of just going, they're like on the ground floor of a mall or something. Can you imagine that? And then they're coming back up to the elevator. I was thinking about, you know, malls have a whole bunch of escalators going up and down. So you can think about it like that. As you go up the escalator to a second floor, you're gaining energy. And then when you go back down the escalator to the first floor, you're losing energy. So it's the same idea. So there's more energy at point B than there is at point A. So this would be the answer for the first one. And then for C and D, C has less energy than D because of the rationale I just gave you right now. As the energy goes through a light bulb, or the charges go through a light bulb, they lose energy. So there'll be less energy at the other side of the bulb than there will be before it goes in. And then for BD, this is it's approximately equal. That's what that squiggle on the top is. So you could have just written equal, because between once the energy comes, the electrons come out of the battery. No, sorry, hold on. Once the energy leaves the battery here, then there's nothing that's changing the energy between point B and D. It has to go through something else besides the wire in order for energy to change. So between point B and D will be the same. And then you weren't asked this, but over here on this side, the energy at the potential difference of point A is going to be equal to the potential difference of point C. Right. This concept here can be quite confusing, and we're actually going to revisit this idea later on when we can later on in this unit while we continue our investigation on circuits. Right. It would be really helpful if you actually draw this into your notes as well, so you can keep this as a reference. So if you can press pause now to do that. Alrighty. So the last thing for today is an exit ticket. This is kind of tying in together what we learned yesterday and what we learned today. So using the schematic model that we did learn yesterday, drawing circuits, you want to draw a circuit that has 2 times the amount of energy and 3 times the resistance as the circuit that's drawn below. And then you'll compare and contrast both of these circuits. So here we have like 2 cell batteries and 2 resistors. So take the next 3 minutes or so to draw this into your notes. It would be helpful if you send a picture of this to your teacher so that we could see how you did these drawings. Once you're done completing the exit ticket, don't forget to submit your work on Google Classroom, both your classwork and the picture of this diagram. I hope you have a fantastic day, and I'll see you all tomorrow.